All right, we're going to do just a short review together of the lessons that we learned this week. So this first one says, write the equation of an ellipse with its center at the origin. Based on the given information, you can graph it if you want, but you don't have to. I'm going to graph them just to show you what is going on. So this first one says you have a co-vertex of 2, 0. So 1, 2, 0 is one of your co-vertices. And then a vertex of 0, 6. So 1, 2, 3, 4, 5, 6 would be a vertex of yours. That means because we're centered at the origin, which is all you've learned so far, your other vertex would be at 0, -6, and your other co-vertex would be right here. So your ellipse looks something like this. We know with an ellipse, our equation is always going to be x squared over something plus y squared over something equals 1. So we have to figure out, this is our a squared, right? And this one is our b squared. So a is going to be the distance to our co-vertices here because it's the shorter. So 2 is our distance there. So it's 2 squared, which is going to be 4. And then our b value is the vertical distance. And our b value here is, what was that, 6? So that's going to be 6 squared or 36. So it's going to look just like that. All right, number 2, you have a foci. You have 2 foci. You have a focus, 2 foci at 0 plus or minus 4. So 0 plus 4, 1, 2, 3, 4 up. That's one of your foci. And then down 4, 1, 2, 3, 4. That's your other focus. And then co-vertices at plus or minus 2. So 1, 2, 0, and -2, 0. Those are your co-vertices. Okay. We don't know our vertices yet, but we're going to find them. But we always know with these, whenever it is an ellipse, it's always x squared over something plus y squared over something equals 1 is our general setup for that. So we just need to figure out, again, our a squared is going to go here, and our b squared is going to go here. Now, we have our a. A is our horizontal distance, okay? So from center to our co-vertices there, that's going to be a 2 squared. So 4, right? That's 2 squared. And then our y, we don't have our vertices yet, but we do have our focus, which means we have our c. And if you recall, to find our foci, the equation was c squared equals, and then in this one, it's the bigger minus the smaller. So this is going to be b squared minus a squared, okay? Because our b is going to be up here somewhere, which is bigger than the 2 that it takes to get to our co-vertices. Your vertices are always going to be the bigger ones with ellipses. So what we're going to do is we're going to plug in what we know. This length here is our c. So from 0 to the focus is always the c, or from our center to the focus. So 1, 2, 3, 4 units is our c. So 4 squared. B squared is what we're solving for. And then minus a squared. And this one we already know what a squared is. It's 4. So we have 16 equals b squared minus 4. So add 4 to both sides, and we get b squared equals 20. Now it's tempting to want to square root that, but we're looking for b squared. So don't square root it, just drop that 20 in, and you're done. All right, given the ellipse, x squared over 16 plus y squared over 25 equals 1, graph and find the following. So we're going to graph it, find the vertices, find the co-vertices, and find the foci. So if you look at this, this is always your a squared. So that's going to be 4 squared. That means a is going to be 4. This is your b squared. So if 25 is b squared, then b is going to be 5. So when we set this up, we would graph this. If a is 4, that's 4 units to the right. and 4 units to the left. If B is 5, that's 1, 2, 3, 4, 5 units up, and 1, 2, 3, 4, 5 units down. Okay, so this is what our ellipse looks like. Okay, so our vertices, those are always the major axis. Those are always the ones that are farthest away from the center. So our vertices right now are these two, right? That is going to be 0 plus or minus 5. Okay, those are our vertices. Our co-vertices are the left and the right, those two. So that's going to be your x value, plus or minus 4 and 0. Okay, if you like to write it as 0, 5 and 0, negative 5, that's fine too. This is just a simpler way to write it. So then we need to find the foci, and we know the foci are going to be somewhere here and here because they have to be on the same axis as the vertices, okay? So coming up with our foci, remember we need to find our C is what's going to go in right here. So to find C, this is always C squared equals the bigger number squared minus the smaller number squared. So equals our B squared minus our A squared. Okay, so when we do that, we get C squared equals 9, which means C is plus or minus 3. So your foci, 1, 2, 3, and 1, 2, 3 are going to fall right there. So that's 0 plus or minus 3. Number 4. This one, it says write the equation for the hyperbola. So now we're switching gears to hyperbolas. Hyperbolas, remember, are the ones that go like this or like that, okay? With a center at the origin based on the given information. So our foci are at plus or minus 2, 0. So negative 2, 0 is a focus and 1, 2, 0 is a focus. So there are your foci. Your vertices are plus or minus 1, 0. So 1 and negative 1, negative 1, 0, and 1, 0. So this is a vertex, this is a vertex, which means that our curve, okay, now you could draw the whole like box in, but I just want you to see your curve should be wrapping around the foci, right? So it's going to be something like this. Technically, you don't have to graph this one. It doesn't say to graph it. I just put the graphs there so that you could help visualize it if that's helpful to you. But remember, hyperbolas, we're subtracting now. So it matters which one comes first, your x squared or your y squared. Because our vertices are on our x-axis, our x's are going to come first. So it's going to be x squared over our a, okay, that's this number, the distance from the center to the vertices, so over 1 squared, so that'd be over 1. This is minus now, and then it's going to be y squared over something equals 1. Okay, so we know that's going to be the general format. We need to figure out what our b squared is. Well, we know that our a term is 1, okay, and we know that our c is 2. Okay, so if we plug that into c squared, remember when your equation has a minus, then your foci equation has the plus. So it doesn't matter a squared plus b squared or b squared plus a squared, because those are commutative. So we're going to do c squared, our c was 2, so 2 squared equals a squared, 1 squared, plus b squared. Okay, so take away 1 squared. 4 minus 1 is 3. And again, it's tempting to want to square root that, but we're just dropping it into the equation, and we want b squared there. So you're just going to drop it in as a 3, and it's going to look like that. Okay. Okay. Number 5. It says you have foci at 0 plus or minus 4. So 1, 2, 3, 4. That's one focus, 1, 2, 3, 4. That's your other focus. It says your vertices are at 0 plus or minus 2. So 1, 2, and 1, 2, So vertex and vertex, which means our, again, hyperbolas are following, ooh, that was terrible, this general curve, right? Opening up and opening down. So what we're going to do here is we're going to try to figure out what is our equation. And remember, your vertices always come first in hyperbolas, and our vertices are on the y-axis. So it's going to be our y squared first. So it's y squared over something minus x squared over something equals 1. Okay, well, we know our b value. Our b value is right here, a length of 2. Okay, so this is over b squared, right? So 2 squared is going to be 4. We also know our c value, and c, 2, 3, 4, c is 4. Okay, you could find that here as well. So c is 4, b is 2, and we're looking for a, because a squared is going to go right here. Okay, so plug it into the formula. C squared equals a squared plus b squared. Remember, this is addition because this is subtraction. It's always the opposite. So we get 4 squared, so 16, equals a squared is what we're solving for, plus b squared, which would be 2 squared. So take away that 4, and we get 12 for our a squared. And we want a squared, oops, I'm not even going to plug that in there. A squared is 12. That's what's going to go right here. So it's y squared over 4 minus x squared over 12 equals 1. Okay, last one. It says given the hyperbola, so now we have our equation, graph and find the following. So we need to find our vertices. Notice what is first. Y is first. So that means our vertices are going to be on the y-axis, okay? This is b squared, so that means b is the square root of 4, or 2, okay? That means my vertices are plus 2 and minus 2. The way we write that is 0 plus or minus 2. Okay, so those are our vertices. Then notice this. That means our a squared is 9, so a is plus or minus 3. So if I go 1, 2, 3 to the right and 1, 2, 3 to the left, remember those aren't points. They're just going to help us make our box. So if we put our rectangle here, okay, and then draw our asymptotes in, that means our curve is going to look something like that. Remember, you just kind of follow along those asymptotes. So our graph looks like that. Our asymptotes then is rise over run, if you recall. So if I start at the center and I go up and over, okay, that's up 2 over 3. So our asymptotes are the equation y equals plus or minus 2 over 3 times x. Okay, and your asymptote will always be that format, y equals plus or minus something x. Rise over run. Okay, so there's our asymptotes. Then we need our foci, and our foci are going to end up here and here. Okay, so I know right now that my foci have to be 0 something, okay, because I'm going up on the y-axis and down on the y-axis. So because we're subtracting, our equation should be adding. Okay, that's our c squared equals a squared plus b squared. We don't know c, that's what we're looking for. A squared, we already said was 9. B squared, we already said is 4. So c squared is 13, which means if we take the square root of that, c is plus or minus the square root of 13. Well, that is what goes here, right? Our foci in this situation is going to be 0c. So 0 plus or minus 13. All right, just a little bit of extra review there to keep it fresh in your brain through the weekend here. Have a lovely weekend.